Huh.
It does something funny. Usually, I see the person enter the meeting, and then it takes 3 or 4 seconds before the tone goes off telling me I have audio with them.
So,
And yours does it in reverse. So, do you have spring break next week?
yeah, I do. I don't have school tomorrow, so.
Okay. Does everybody get off tomorrow also?
So, can you go back to that website that you saved?
I can. Before I do that, I want to review something. You told me last time we worked that you had difficulty. You got confused when it's positive and negative numbers. So I would like to go over that. I can do nothing better for you than to clarify this. When you have the sum of 2 positive numbers, it's equal to that. When you have the sum of 2 negative numbers, what is it equal to?
-5.
The only other situation you can have is the sum of a negative and a positive. What is that?
1.
And finally, a positive added to a negative. What is that?
-1.
Okay, so that is the only 4 ways you can add 2 numbers. That covers all possible situations. So you understand addition for sure.
Yeah.
Is that?
2.
What is that?
-2.
What is that?
2. Oh, no. This one is different. It's
Yes.
-19.
Negative 16.
Or 16.
Uh-huh. And then finally, if I have a positive number minus a minus number, that's the only other situation.
16.
Okay. Now, of these, I know you know how to do that. I know you know how to do that. This probably is the only of the 8 situations that give you trouble. And the way to avoid trouble on this is to turn it into an addition problem.
I'm losing your audio.
I said, can you hear me now, Grace? Grace?
Huh?
Can you hear me?
Yeah.
Okay.
I'm losing you.
Let's see if it has any audio difficulties here. Do you have a speaker phone that you could talk on without having to hold it up to your ear? Do you have a good speaker phone, like a landline?
I don't know.
All right. Well, let's continue on as is now. So, of these, and let me know if you have trouble hearing me. Of these, this is the only one that's going to give you difficulty. And if we change this into an addition problem by changing the subtraction sign to a plus and making the sign on the 9 minus, then that won't give you problem. So we've just covered all possible combinations of adding and subtracting numbers. All right, let me go to that website.
Okay.
CPM ebooks, right?
Yeah.
Well, I didn't remember. What's your username again?
GR1.
And your password?
And then 2066.
2036?
76.
2076. Okay, which chapter?
7. And we're in 7.2.1.
Okay. You have a specific one you want to start on?
Well, she's doing that all right there. I can't figure that out. She's doing this thing where it's like cube root, and then it's got fractions in it.
Let's talk about these problems here. Excuse me while I get my screen set up. Okay. All right. 10 to the 2/3. When you have a fractional exponent, the numerator is like squaring it. The denominator is like the cube root of it. So before we tackle a tough one like this, let's tackle an easy one. What does the cube root of 8 equal to?
I don't know.
2. What cube root means is what number multiplied by itself 3 times equals 8. So 2 times 2 times 2 equals 8. Therefore, 2 is the cube root of 8. What is the cube root of 27?
9.
9
No.
times 9 times 9 gives you way too many. It's a whole number for sure. 3. Because 3 times 3 times 3 equals 27. Okay? So that's what cube root means. Cube root's a little different than square root in that we can take the cube root of a negative number. What is that?
-3s.
Negative 2.
Or -2.
Why? Because negative 2 times negative 2 times negative 2 is equal to negative 8. Okay? So, right off the get-go, we see where cube roots are different than square roots. You can't take the square root of a negative number. But you can take the cube root of a negative number. You can take the cube root of a positive number also, but that's equal to +2. So there's no plus or minus when you're talking cubes. That's just with square roots where you have plus and minuses answers. Now, if I did this, that would mean the same thing as the cube root of 8 squared. That's the first thing to understand. So the denominator of the exponent is the root, and the numerator of the exponent is squaring or whatever. If this was 3/4, it would be the 4th root, and I would cube the 8. When you get problems like this, always do the denominator first. What is the cube root of 8?
2.
So this is the same as 2 squared. Now, had I done the numerator first, it would have been the cube root of 64, which is also 4. It's just that when I do the numerator first, I have to deal with bigger numbers, and that's always opening up possibilities for more mistakes. So always when you see a fractional exponent like this, do the bottom first. Now, why they put such tough ones on here, I don't know. These don't make any sense at all. Let's see what we can do here. Okay. Find ways to rewrite the expression below. So they don't want us to solve it, they just want us to rewrite it. Hold on. So 10 to the 2/3. What's a different way to write that?
I don't know.
How about the cube root of 10 squared? That's one way to write it. They say write it in two different ways. Well, okay, I'll write it in a different way. There's my second way. Notice why this is equal to 10 to the 2/3. We're going to multiply exponents because we're exponentiating here. Okay? So this is the two different ways that we can write when we have an exponent like that. All right, let's look at the next one. The cube root of 9 all to the 4th power. So let's write this with a single exponent. What would it be?
What do you mean?
Well, A is written with a single exponent, and we turned it into writing it kind of like this. Well, this one,
4/3?
yeah, very good. In other words, the bottom is the root, the top is the, I don't know what you want to call that. Okay, and let's see, is there another way we could write that? I think what they have in mind is this. That's the cube root of 9. There's the other way to write it. Okay?
Okay.
All right. 5th root of x cubed. What's the single exponent way to write this?
3/5.
What's the exponential way to write this? It's like that. In other words, is all I'm doing in the second way is taking the top out, x cubed, and then taking the 5th root of that. As long as we know that when I put that back together again, I have x to the 3/5, then it has to be the same as x to the 3/5. All right. Square root of 2 to the 5th. What's another way of writing this? What exponent is the same as square root of?
2.
1/2. Just like cube root is 1/3, square root is 1/2. Fourth root is 1/4. So if this is the way we write square root of 2, then how do I write this?
5.5.
5/2. In other words, the bottom means square root. The top means we're going to take 2 to the 5th. So the other way I could write that is to write it the way I started to, and then just take that whole thing to the 5th power. So those are the two ways to write that.
Oh boy.
Okay, 5 to the 7/2. What's the bottom mean?
2 square root of 5 to the 7.
Yeah, it's square root of 5, not 2 square roots of 5. In other words, I don't need to write it like that. If I don't write that if it's square root, I leave it blank. It's kind of like if you have a variable and you don't put anything in front of it, we assume there's a 1. Well, when you have a radical sign, if we don't put anything there, we assume it's a 2. If it's cube root, then we have to put 3. Or if it's fourth root, we have to put 4, and so forth. But if it's left blank, it's presumed to be square root. So this is correct. Okay, what's another way? So what power?
To 7.
Uh-huh. Okay. That's another way to write that.
1.
Yeah, just y to the 1, or just y. There's also, they want 2 ways to write it. So what would be another way to write it? We could do cube root of y cubed, or we could do y to the 1/3 cubed. All of these mean the same thing. Alright. So that's the deal with radicals and exponentials, exponents, and stuff like that. Notice this problem here, A. Minus 27 to the 1/2. Why does that have no real solution?
Because it's negative, so when you multiply it by itself, it gives you a positive.
Exactly. In other words, we can't take square roots of negative numbers. But how come minus 27 to the 1/3 is a real number? And what is it?
Because it goes back into a negative.
So that's negative 3. And negative 3 times itself 3 times is negative 27. So again, we can take the odd roots of negative numbers. We just can't take even roots. We also can't take the fourth root of negative 27. There's no number multiplied together by itself 4 times that's going to equal a negative number. So you can take odd roots of negative numbers, but not even roots.
Okay. But for the negative 27 and a quarter, that one you can't do it either.
This one here, that's correct. You cannot do that. However, let's look at this. This is this first one here. What is negative 27? This one's always bothers me a little bit. Negative 27 to the 2/3. Given that that equals negative 3, is this positive or negative?
Negative.
Well, let's take the cube root of negative 27 first. In other words, if we say that it's equal to this, excuse me, okay, so that's the way we're going to do the problem. The cube root of negative 27 is minus 3. Minus 3 squared is positive 9. Even if we do the squaring first, when we square negative 27, we get a positive big number. And then when we take the cube root of a positive big number, we get a positive number. So this is positive no matter which you do first. No matter whether you take the cube root first and then square it, or if you square it first and then take the cube root. In other words, I could also write this slightly different. I can write it as minus 27 squared, and then I'm going to take the cube root of that whole thing.
That's confusing.
It is, but that's the whole point of these exercises, is to show you how to look at fractional exponents. Fractional exponents just mean you square that and you take the cube root of that. In either order you want. Doesn't matter, you're going to get the same answer. But I'm just telling you that the problems you're going to encounter, you're going to always be better off taking the cube root first. You see why here? When I take the cube root of negative 27, I get a small number. Now when I square that small number, I still have a decently small number. I don't have to deal in any big numbers at all to come up with the answer. But if I square negative 27 first, what is that?
Some big number.
7 squared is 729, and it's positive. So it's 729 to the 1/3 power now. And even though that is equal to 9, I had to deal with this huge giant number, 729, because I did it in reverse order. I squared it first, took the cube root next. So always remember to do the bottom first. And the problems you're going to get at this level, that's the bottom usually is going to give you a whole number. In other words, they're not going to give you a problem like this. It's too hard. There is no nice whole number that is the cube root of negative 26. So they're always going to make these so that when you do the bottom first, you get a whole number. That's why the kind of problems you generally see are problems like that, because the cube root of 8 is 2, or that because the cube root of 27 is 3, or even something like this. The cube root of 64 is 4. So 4 squared is 16. So that's equal to 16. This is equal to 4. This is equal to 9. All right. would just proceed along these lines here.
Yeah. There's one of them that she did that she gave us 2 points and we had to plug them into y equals mx plus b.
Okay.
And they had like exponents and I didn't do that.
Well, I'm not quite sure what that means.
Scroll down.
Sounds like you mean a problem like this, where you're not really plugging into y equal mx plus b, you're plugging into y equal a times b to the x, an exponential.
No, it wasn't. It wasn't that.
Okay.
I don't know what it was, but we can do that one.
Let's do this one right here. If 3 equals a times b to the 0, and 75 equals ab squared, can we solve for a and b? Start with the first one. What does b to the 0 equal to?
1.
We just solved for a. A equals 3. So now, let's plug in 3. You still there? I think I lost the audio somehow. You're back.
That was weird.
I lost the audio for about 10 seconds. Okay,
Sorry.
so that first one allowed us to solve for a. It's 3. We substituted into the second one, now solve that. B squared equals what?
75 over b squared.
Well, 75 divided by 3, which is 25. And now what do I do? How do I solve that for b?
B would be 5.
Yeah, we can take the square root of both sides. In other words, I'm going to take the square root of that, I'm going to take the square root of that. Square root of b squared is b. Square root of 25 is 5. It's actually plus or minus 5, but since we're dealing with exponentials, b is always positive, so we ignore the negative, which means we have our solution. A equal 3, b equal 5, and the equation is y equal 3 times 5 to the x power. That's the final solution. All right, we're only doing a half hour today, Grace?
Yeah.
Okay. Okay, well, I probably won't talk to you again until a couple weeks, because next week is spring break, right?
Yeah.
All right. Well, you enjoy your spring break. I'll talk to you in a couple
You too.
weeks. All right. Bye-bye.
Okay.